In this video, we will look at a problem from machines chapter. That is, the question says a 4-meter long rod of negligible weight. The weight is negligible. Negligible weight, this needs to be noted, is supported at a point 125 centimeters from its one end. That is, supported means the fulcrum is there. That means the fulcrum is there at 125 centimeters from its one end, and a load of 18 kgf is suspended at a point 60 centimeters from the support on the shorter arm. And then there are 3 subparts to this question. As soon as the question is given, the most important thing is that we need to draw the figure. Let's draw the figure. It's a 4-meter long rod. That means this is the rod, and we have 0 on one side and 400 centimeter at the other end of it. So we need to mark as soon as that 100 centimeter or 1 meter rod. So we need to mark 0 and 400, and it is supported at 125 centimeters from one end. And then an 18 kgf load is suspended at 60 centimeters from the fulcrum. That means it is from 65 centimeters from the one end. And then there is another weight, that is W, which is suspended at 250 centimeters from the fulcrum. That is the A part of the weight. So this is the A part of the weight. Then what is the magnitude of the weight? We need to just apply the law of the levers. Law of the levers is equal to, it is nothing but the principle of moments. That is, clockwise moments is equal to anti-clockwise moments. So if we take the weight 18 kgf, it will produce a anti-clockwise moment. And then the weight W produces a clockwise movement. Both needs to be balanced, because the law of levers, the lever has to be in equilibrium position. So then if I take this 18 kgf weight, that 18 kgf is 60 centimeters from my fulcrum. So that is 18 kgf multiplied by distance, that is my moment of force, is equal to W multiplied by, it is 250 centimeters from the fulcrum. So W into 250 centimeters. When I solve for W, the W I would get it as 18 times 6 divided by 25, which would be 4.32 kgf. That means the weight W must be 4.32 kgf. The second part of the bit says, then the left side remains the same. That is, an 18 kgf force is added at a distance 60 centimeters from the fulcrum, but there is a 5 kgf force which is balancing this 18 kgf force, which is added on the other side at a distance of d, which we do not know, and that distance we need to find out. So the figure corresponding to that description is as given here. Now if we see again, we apply the law of the levers or the principle of movements, then we have anti-clockwise movement, that is produced by 18 kgf, that is equal to 18 multiplied by the distance from the fulcrum is 60, is equal to the clockwise movement produced by 5 kgf, which is 5 multiplied by the distance. When I solve for a distance, that is 5 goes 12 times, and 12 18s are 216. The distance is 216. The third subpart of the question is asking you what kind of what class of the lever does it belong to. The class of the lever is, when we plot the lever, this is the lever, and my fulcrum is here. Whether one side either it is a load or effort, on the other side then the load or effort will be there. So fulcrum is in the middle. When the fulcrum is in the middle, it belongs to class 1 of the lever. So remember the numeric FLE 1 2 3. So FLE 1 2 3 says that fulcrum is in the middle, then that is class 1 lever. Load is in the middle, that is class 2 lever, and effort is in the middle, that is class 3 lever.